This is an integral that I want to show you today. So we have the integral from 0 to infinity of x minus 1 over square root of 2 to the x minus 1 times natural log of 2 to the x minus 1 dx. So the first thing that we are going to do is that we are going to let a substitution where we let t squared is equal to 2 to the x minus 1, which you can solve for x, which is x is equal to natural log of t squared plus 1 over natural log of 2. And now we have that 2t dt is equal to natural log of 2 times 2 to the x dx, which you can then write it as natural log of 2 times t squared plus 1, just replacing 2 to the x power by t squared plus 1. And now we can substitute everything into this integral, and then this will transform the integral into the integral from 0 to infinity, where we can check the bounds remains the same. And then we have x is natural log of t squared plus 1 over natural log of 2 minus 1 over 2t natural log of t times 2t over natural log of 2 t squared plus 1 dt. Okay, so now we can see that the 2t will cancel off, and then by some simplification and manipulations, you will get that this is equal to the integral from 0 to infinity. Oh, there is a constant in front, which it is actually 1 over the square of natural log of 2. And then the integrand will be natural log of t squared plus 1 minus natural log of 2 all over t squared plus 1 natural log of t dt. Okay, so now I will denote this whole thing as the integral I. And then we shall now perform another substitution on this integral I, which the substitution is by letting t to be 1 over t. And by doing this, what you will observe is that, well, this is an exercise for you to figure it out. After doing this substitution, what you get is that 1 over square of natural log of 2 remains the same, and the integral from 0 to infinity, we replace all the t's by 1 over t, so we have 1 over t squared plus 1 over t squared plus 1 natural log of 1 over t, and then the dt will be 1 over t squared dt. And note that the negative sign, there should be a negative sign, which the sign has been used to flip the bounds of integration. And then we can then simplify this, and we will get that this is negative 1 over natural log of 2, the whole thing square, and the integral from 0 to infinity natural log of t squared plus 1 minus natural log of 2 minus 2 natural log of t all over t squared plus 1 natural log of t dt. Now, this is also the same integral, which is the integral I. Then, we shall now add up these two integrals, and what we will get is that it is the same thing as 1 over natural log of 2, the whole thing squared, the integral from 0 to infinity natural log of t squared plus 1 minus natural log of 2 over t squared plus 1 natural log of t minus the similar term, which is natural log of t squared plus 1 minus natural log of 2 minus 2 natural log of t all over t squared plus 1 natural log of t inside the big bracket dt. And now we can see that what we have here is that this term will cancel out with this term, and this term also cancels with this term. And then if you combine this, what we end up is just a simple integral, which is 1 over natural log of 2 square, the integral from 0 to infinity, 2 natural log of t over t squared plus 1 natural log of t dt. And now the natural log of t cancel off, and then this integral is just 2 over natural log of 2, the whole thing square, the integral from 0 to infinity of 1 over t squared plus 1 dt, and this is the integral of which the antiderivative is equal to the arctan of t evaluated from infinity, from 0 to infinity, my bad, and this is just the same thing as pi over natural log of 2, the whole thing squared, which this is 2t, so this means that I, which is our integral over here, is the same thing as pi over 2 times natural log of 2, the whole thing squared. Okay, now I want to present another method to compute this integral. So this is an alternative to the solution presented above. So the alternative here to evaluate this integral from 0 to infinity of x minus 1 over square root of 2x minus 1 times the natural log of 2 to the x minus 1 dx, it is to perform another substitution which is different from our first substitution, which is by letting u to be equal to natural log of 2 to the x minus 1, and then you can solve for x, which is x is equal to natural log of 1 plus e to the u over natural log of 2. And now we have that dx is the same thing as 1 over natural log of 2 e to the u over 1 plus e to the u du. And now I will write this term as 1 over natural log of 2 du over 1 plus e to the negative u. And you will see why I write in this form. So this transforms the integral into the bounds of integration will be negative infinity to infinity, where we can check that. And then we have natural log of 1 plus e to the u over natural log of 2 minus 1 over e to the u over 2 times u, and then the dx will be 1 over natural log of 2 du over 1 plus e to the negative u. Okay, and then by pulling out the constant part, it is 1 over natural log of 2 square, the integral from negative infinity to infinity, and the integrand will be natural log of 1 plus e to the u minus natural log of 2 over u times e to the u over 2 plus e to the negative u over 2 du. And now we can actually split the integral into two parts, which is 1 over natural log of 2, the whole thing squared. I'll split this into negative infinity to 0, and the integrand will be the same. So it is du plus the integral from 0 to infinity of essentially the same thing, du. And now we can look at this integral over here, and let's perform a substitution which will let u to be negative u. Okay, and then by doing this, this will transform it into the integral from 0 to infinity. We have natural log of 1 plus e to the negative u minus natural log of 2 all over negative u e to the u over 2 plus e to the negative u over 2 du. And then the second part is the same. Okay, now what we can see over here is that we can take this negative sign and multiply it on the top, and what you will eventually get, which you can check, most of the terms will be cancelled off, and the thing that we are left with is just the integral from 0 to infinity of 1 over e to the u over 2 plus e to the negative u over 2 du. So this is a simple integral where you can just notice that it is the same thing as the integral from 0 to infinity e to the u over 2 over e to the u over 2 the whole thing squared plus 1 du. And for this, it is actually the same thing as 2 over natural log of 2 the whole thing squared times the arctan of e to the u over 2 the whole thing evaluated from 0 to infinity, which the answer is just pi over 2 natural log of 2 the whole thing squared. Okay, so this is the answer that we want. So actually, a much more general form would be that if we have the integral from 0 to infinity x minus 1 over square root of a to the x minus 1 times the natural log of a to the x minus 1 dx, it will be the same thing as pi over 2 times natural log of a the whole thing squared, where a here is a real number that is greater than 1. So you can try this on your own. The method is similar to what we have just discussed before.